Wow, thank you very much. It's pretty new for me. This is going to be my first talk in English, and I'm pretty excited about it. I am not nervous because I am between Rob Pike and René Fritsch. I am totally cool with that. Well, my talk it's about a project I am part of. This project is named Lantern. I'm going to talk to you about Lantern. Lantern is a closed platform application for Mac, Windows, and Linux. People can use Lantern to circumvent restrictions on a local network and get to the open internet. Lantern is sponsored by Brave New Software Project, Inc., and I am part of that team. And this is a nonprofit. Let's see a diagram on how Lantern works. We see here at the bottom, we have a consumer, a mobile phone. We see in the middle that we have a sensor represented by this wall. And we have different sites there. We have site A, site B, and site C. So let's represent the content of the sites with animals. And let's suppose we have a sensor in between that determines that the sites for you, that decides in your place what is better for you to learn and what you should not be learning. For instance, maybe the sensor thinks that you may not like watching cat videos on the internet, so he says no. He forbids you to connect to popular sites where you can watch cat videos. Let's suppose the sensor does not like animals with large ears, so he forbids the access to rabbit sites. But maybe the sensor likes bees, so he thinks bees are cute. So he allows you to go to bee sites. And the result is that the sensor controls what you are seeing. And so the result is that the consumer is only able to see bees. Okay, this is a schema of how Lantern helps you deal with that. We have a program that connects to Lantern, and Lantern is a program that creates a local HTTP proxy. This proxy opens support in your local host, and this is the Lantern client. The Lantern client goes through your usual connection to the internet, but it implements some special circumvention techniques that allows Lantern to pass through the firewall without making by disguising a bit the traffic you are generating. So the result is that thanks to some special circumvention techniques, Lantern is able to reach its external proxies, which is it's a network of different servers that live in different VPSs. And that way, Lantern can help you to reach the open internet. It forwards data from the real site into the Lantern client, and the Lantern client forwards the thing you want to see to the program. Let's see a demo of this. Suppose we want to access a popular site, Wikipedia, in order to learn from something that is currently happening, an historic event, for instance, and we don't have access to it. But we can start Lantern, and we can refresh the page. And then we pass through the censorship page, and we reach the Wikipedia. Okay, you may have noticed that we have that I used this number, and this number is a new HTTP error that got added some time ago, last year I think. It means that that the content you are trying to see is unavailable for legal reasons. This is of course a reference from Fahrenheit 451 from Ray Bradbury, and I want you to And the thing I am trying to tell is that you can use Lantern to circumvent this, to bypass this error and convert it into a successful response. Okay, getting more into the technical details of Lantern, I'm going to explain you how Lantern works, how the HTTP proxy server works. We have a command in the top. It's a curl instruction, and you can instruct curl to use a HTTP proxy server to connect to the resource you are trying to reach. Okay, so Lantern receives a request like the request that is at the bottom. It's a GET request, and instead of passing the /resource.html thing that you will normally use with GET, you pass a full URL. HTTPS works similar, but instead of using GET, post, or whatever you want to do with the destination server, you use connect. And Lantern creates a bridge between between your local machine and the Lantern cloud. And what does this have to do with Go? In Lantern, Go is part of a multilingual ecosystem. We also use JavaScript, Clojure, Python, and whatever we need to get the job done. Both Lantern client and proxy servers are open source and are written in Go. We also have an auto-update server that provides Lantern clients with binary diffs, and this allows the clients to update themselves. So this ensures clients are always up to the latest circumvention techniques. And of course, the main topic of this talk, the Lantern for Android, is powered by Go Mobile. I'd like to put you in context on how we started with Go Mobile. We started on early 2015. We had Go 1.4 there, and Go 1.4 required special setup for cross-compilation. We had the x/mobile repository, and it contained instructions and a Docker image that helps us building applications for Android. And maybe it wasn't too easy to use, but it was good enough for us to get somewhere. This is an example on how to on one of the initial experiments we did while trying to build Lantern for mobile devices. We started doing something like this, and of course it didn't work at the first time because we had a lot of code that was only valid on desktop. So we had to fix our code, and after a few iterations, we were able to build a binary. This binary was a binary that could be run on a mobile device. And in order to run this binary, if you want to do an experiment like this, not with Lantern, but maybe with another program, maybe a Hello World, you can compile it with the environmental variables we saw. You can make sure it's a 32-bit ARM binary, and you can use the ADB tool to push it into your phone, and use the ADB shell to get into a shell into the phone, change permissions, and execute the program. Let's see an example of this. This shell is within the mobile phone, an Android phone, and we are starting the Lantern client there. And in the bottom pane, we are using curl to connect to the IP of the mobile phone, and we request the mobile phone to get us a resource. Okay, this was one of the first experiments that we did, and after we came with something that just worked, we started discussing some projects, and it occurs to us that we could provide a Twitter client, a Twitter client that could circumvent censorship in some places and just provide access to the Twitter network. This client was named, the name of this client was FireTweet. This was our first product, and how we did this? Well, we forked an open source client from Android that already existed, and we built Lantern as a library. We also embedded this library into FireTweet, and we configured FireTweet to use the Lantern client as its HTTP proxy. If we are thinking on code, we did something like this. This is how the initial code looked like, and we had two functions there. We had the start function and we had the stop function. The code is commented out there because it's not well, that's code that it's only valid for us. So in order to save you some time, let's just think that we have two functions, and those two functions were the minimal things we required in order to provide a way for the Android application to start or to stop a proxy. So that's why we have only two functions there. On the Java side of things, we imported the library that is called Flashlight, Flashlight Lantern, you get it? We imported the Flashlight library. We called the start function. And once we called the start function, the Flashlight library started a Lantern proxy. And we used the set property function on Android to set up to configure the application and make it go to the Lantern proxy. Now let's take a small detour here, because 1 year ago, in this very same place, we had GopherCon 2015. We were here in GopherCon 2015, and we were enjoying a talk by Hannah Kim. She was talking about Go Mobile. We learned a lot. We learned a lot about Go Mobile after her talk, and we also discovered that Go 1.5 didn't require a manual bootstrapping anymore. It was easier to build cross-compiled applications with Go 1.5, and everything just got easier. And I'd like to tell you a bit about the Go Mobile command because I think that it is important, and we adopted it in our build scripts that very night. If you want to try the Go Mobile command, then you have to use go get to install it. And the Go Mobile has three main subcommands. The first one is init. You can use init to initialize a development environment that you can use to build Android applications. This subcommand downloads a stripped-down version of the NDK, and it provides you with all the requisites you need to build a Android application right away. The second command I like to tell you about is the Go Mobile bind command. You can use this command to create libraries that you can then import from Java or from Objective-C. If you want to create full standalone applications, then you use Go Mobile build. These can be used for games. The difference between importing as a library is that you need something in the Java or in the Objective-C side that imports that library. But with Go Mobile build, you can create full-screen applications using OpenGL-S or OpenGL-S. And you can also use other libraries like OpenAL to provide some other functionality like audio or video or things like that. Okay. Let's get back to FireTweet. Let's get back on track. We made FireTweet and we published it to the store. and it was fine. But we wanted to proxy the whole device. Also, our users wanted to access different sites and not only Twitter. But we had a problem here. How was Lantern going to proxy traffic from all the other applications? So it was time for a different approach. We had to think again how we are doing things. And we made some research, and we found that Android provides an API which is called VPN Service, the VPN Service API. And the VPN Service API creates a TON device. This is a virtual network interface and help us setting up routing rules and some other things that could be easy to do on a full-featured Linux when you have root and IP tables and all that stuff, but which are not as easy to do on an Android device. A TON device can basically intercept or inject IP packets and interact with an user application. So this means that an user application that an application that lives in user space is able to inject or to capture IP packets. Let's see a schema of this. We have an application that communicates using IP packets with the TON device, which is named TON0. And this TON0 creates a bridge with the physical device, which there is named ETH0. And ETH0 sends the actual packets to the physical network. In this example, the bridge is transparent. It's just forwarding packets from one place to another, and from another place to an actual network. So we have the tool that allows us to work with TON devices with ease, which was VPN Service, and we started to think how to make Lantern communicate with the VPN Service. Okay, so we had to discuss a lot on how to do those things, and it turns out that we really needed something in between, that we were not be able to use Lantern because Lantern didn't read IP packets, raw IP packets. Lantern was a local HTTP proxy, and raw IP packets, well, they are not in the correct format Lantern expected. So how do we make Lantern work with VPN Service? Fortunately, this wasn't a new problem. Some other projects solved this problem before us. So we continued doing research, and we found out that the missing piece, that the piece we were missing was TON2SOCKS. TON2SOCKS is a C program. TON2SOCKS creates a tunnel between a TON device and a SOCKS server. It SOCKSifies the connection. It also provides support for UDP packets, and we use UDP packets for DNS queries and media transmission, video, etc. And another good point of TON2SOCKS was that it was an old and stable solution, and it was already used for other applications that had some success, like Orbit. Okay, so we injected TON2SOCKS in our project. We started using TON2SOCKS, but then we had another problem. This is the connection loop problem, because when TON2SOCKS SOCKSified the connection, and the connection was going back to the TON device, and the TON device captured the packet, and it forwarded the packet to Lantern again. So this was a connection loop. Fortunately for us, the VPN service provided a special call that is used to protect outbound connections, and its name is protect. And it receives a file descriptor, which is named socket here. It allows a socket to go to go directly through the physical device without passing through the TON device. So we needed something that helped us using this protect call from the Go space, because it was Go, the part that was creating the outbound connections. And what we did here was an interface. This is part of the Go code. The part of the Go code in which we were designing how we are going to use the protect call. And what we did here is that we created an interface with a protect method that expected a file descriptor number. And we also had a helper function, a use protector. And please note that we are using an interface there. And on the Java side, we are satisfying that interface by providing a protector object. And this protector object has the requisites, all the requisites, the interface we saw before defined. And please note that this function is calling VPN Service.protect, which is the function from VPN Service we want to use. And there is another important thing here, because the net package from Go does not allow us to get the file descriptor number that easily. So in order to do that, we had to bend things a bit, and we had to implement a local dial function that used system calls directly. And that way, we were able to get the file descriptor number and to pass it to protect, which was the thing that we required in order to have a complete version of Lantern for Android. Now I'd like you to see a demo of Lantern for Android. Let's try to go to the Wikipedia here. We were seeing the same error here, but I'd like you to meet Lantern for Android. Interface is pretty simple. You only have to click on that button to establish a VPN service, and that way the whole phone passes through this VPN service, and then you can access the sites you was trying to access. Thanks. So after all this talk, you may be asking if Go Mobile is ready for production. And I am sorry to say I don't have the definitive answer for that, because we had a specific problem. We had a lot of problems that were related to networking and to special stuff that were only specific for us. And I think that different problems require different solutions. But it worked for us. It helped us deliver a Lantern for Android. And chances are Go Mobile might be good for you as well. What I did is I came up with a list of things that may help you deciding if Go Mobile is for you. Let's see the good parts. And the first good part about Go Mobile is that it's running Go, and we love Go. And yeah, that's true, but this isn't a valid reason. One of the valid reasons I can give you is that you can use part of your existing code for if you're already using Go, you can import part of this code or modify your application in order for it to build both on desktop or mobile devices. So you can share code between whatever your Go program is prepared to do, and between the mobile device. And you can use concurrency. You can just expect it to work. And network programming is pretty different in Go from Java or from Objective-C. Probably, I may say that doing network programming is maybe easier on Go. So I think that's a good point. Go code can be tested easily apart from Java or Objective-C. You can use Go test for that. Another good point is that Go Mobile generates a .aar file, and you can provide that AR file to third parties for them to use. This is a binary file. You don't have to share your code. And other parties don't have to compile your whole thing in order to use it. And you have access to the whole Go library, to the whole Go standard library. But you have to know that not everything works as expected. I have a few examples that I'd like to share you later. And what about the bad parts? Well, according to the Go mobile team, crossing language boundaries between Go and another language carries a performance penalty. This means that it could be slow. It does not have native UI. If you're expecting to work to code UI with Go, you may be out of luck. Maybe we'll have a surprise here, but I don't really know. I am not part of the Go mobile team, so I can tell. But I hope we can get a surprise there. While Android works pretty good, it's fine. iOS needs more work. It's not as easy as it's not as easy as doing the same but with Android. And some parts of the standard library may not be available or maybe have differently. So an example that comes to my mind is the OS/user package. The OS/user package has a function. It's home dir, I think, and this gives you the path of the home path of the user that is currently using the Go program. And this is not defined on Android. And this is because Android does not have the concept. Well, by default, it does not have the concept of users. And if you don't have the concept of users, you don't have the concept of the home of a user. In summary, Go Mobile is a wrapper around Go that makes it pretty easy to compile for mobile architectures and to package and to create package that works on mobile architectures. And Go Mobile is experimental, but it already can be used to get things done. You can use, for instance, you can use Go here, for instance, to provide services, long-running servers, or maybe a wrapper around a REST API in Go that you can use from Java, perhaps. Maybe you can use an embedded database or whatever program you love in Go. Maybe you can use it on your mobile phone. Or in our case, we did a lot of networking programming, and it was not as difficult for us to come with a solution. And the numbers of our case. Today, Lantern for Android has 1.7 million monthly users. We have 4.5 million all-time unique users and 258 daily active users. So don't be afraid to experiment. Experimental software has bugs, but just try it. What can go wrong? Seriously, try Go Mobile. You have 2 resources there. We don't have a lot of information on how to do things, but I assure you that the tools we have now are good enough to get starting working and provide and get things done. Gracias.